Hello, welcome to 1510 lab number 6, redox titrations. Two parts. The first part is a volumetric part. So we're going to be dealing with volumes, and then the second part, as you see, is a mass-based approach to titrations. So, potassium permanganate. Most wonderful color, kind of nice purple color here. We want to determine the exact concentration of the KMnO4, potassium permanganate. Why do that? Well, it turns out that when they sell you potassium permanganate, they just tell you it's about 95% pure, whatever the number is. But beyond that, it kind of decomposes with storage. So when you get it, a year down the road, who knows? And hence the need to standardize. You can't just say, I weighed out so much, therefore the concentration is expected to be so much. You actually need to determine it. So here's a burette. What's a burette? Well, it's that tube we put in the potassium permanganate solution. It reads 0 up here all the way to 50 down there. And so as we go through, I'll have you actually look at those numbers. How we're going to standardize? We're going to use a compound that's well behaved, that reacts with the potassium permanganate. That compound is ferrous ammonium sulfate hexahydrate. It's Fe2+. So basically, the permanganate as an oxidizer oxidizes the iron 2+ to iron 3. The stoichiometry of the reaction you can find in your lab readings. It is 1 mole of potassium permanganate reacting with 5 moles of the iron 2+. And in order for something to take over the oxygens from the permanganate, we'll add sulfuric acid. So, our reagent is already in there. We need to weigh out an appropriate amount of the iron, the ferrous ammonium sulfate hexahydrate. And it calls for 0.5, pretty close to 0.5. So let's go to the weighing station and do that. We are going to perform 3 runs. The first run is the trial run, meaning we go through it very quickly, to give us an estimate of the volume in the burette that will actually be needed. So again, I tear the balance, and I'm looking for 0.5. Onto the weighing board. I've exceeded it. See if I got it right this time. Nice and slow, little by little. All right, I'll go with that. So the first one that we're going to use for the trial run is 0.506 grams of the ferrous ammonium sulfate. Put that over here. Remember which one it is. And for the actual runs, I'm going to do 2 of them. Tear the balance. That'll work. So run number 1, 0.524 grams of the ferrous ammonium sulfate hexahydrate. And then my third and final one for run number 2 will be, let's see, okay, the balance. .502 grams for the third one. All right. Now I'm going to go to the titration stations. That's my trial run. Run number 1, run number 2. You'll note I've put in a stir bar there to stir the solution as I go. So the first order of business is to read the burette. That'll be challenging. So let me make sure I'm below the level, and then we'll do the best that we can. See where the numbers are. Already run some more here. All right. So we have the 0 line there, and then the 1 here. So each division is 0.1. So I'll read this as 1.3. 1.3. No, let me make it 1.25. 1.25 milliliters is the initial volume in the burette. I'll put it back in there. Make sure it's not dripping. Our reagent is there. We are now going to put in the 25 milliliters of sulfuric acid. It's also part of the equation, the H plus in the stoichiometric equation in the reading. Again here, it's in excess. Put it in. I'm now going to add my ferrous ammonium sulfate hexahydrate. Make sure I get it all in there. Put that back in place, and I'll stir. I'm ready for the trial. What's the purpose of the trial? Want to be able to go quickly until we get some idea of where the endpoint will be, and then it will help us function properly for the real run. So for this one, I just kind of open, and how are we going to tell when we've reached the endpoint? It turns out that potassium permanganate is intensely colored. So when we get to the end point, it will impart the color of this into our Erlenmeyer flask. For whatever reason, this is coming out at an angle. That's not so good. All right. Again, this is a trial run to give us just some indication of what to expect. So what we're going to do here is we're going to see the solution kind of turn a little yellow. The reason is we're forming iron 3+, and iron 3+ have a kind of yellow in it. So we'll look for that, and then we'll add phosphoric acid. The role of the phosphoric acid is to complex or kind of hold on to the iron 3+ so it doesn't interfere color-wise as we seek our endpoint. All right, at this point, I will slow it down, add my phosphoric acid, and here normally, if this were a real run, I'd have to stop and get a thing that works properly, but because it's a trial run, it doesn't really matter. So anyway, start the mixing again here. You can see much of the yellow color we were kind of seeing, a little bit of it is now gone thanks to the phosphoric acid. What you can see is a tint of the purple kind of spreading into the solution more and more as we get closer and closer to the end point. Aha! There we go. I could have gone drop by drop to get the exact, but this is a trial. So what does that say? We went from 1.25 to a final volume, in this case, of 25.2. So what does that say? It says we need something like 23, 24 milliliters to get to react with the 0.5 of the ferrous ammonium sulfate. So that gives us an idea, so that we're not wasting a lot of time when we come to the trial runs, to the real runs, rather. So I'll turn this off now. Won't be able to read. There we are. Here's a tricky part to do on the video. Each of those is 0.1, each of those divisions. So 1, 2, 3, 4, and 5. So I'm going to read this as 1, 2, 3, 4. I'm going to read this bottom of the meniscus as 0.50 milliliters. All right, so I go there. I'm going to take my sample, the second one, or the first trial one. Should be able to go back in the video and record the exact mass. I'm going to put it in. Make sure I put everything in there. If I'm not sure, I can actually wash it down here with some water. It's all in there. I'm now going to add my sulfuric acid 25 milliliters is prescribed. Again, this is in excess of the reagent. At this point, I'll get my phosphoric acid ready. Again, here in this case, it calls for 10 milliliters, 10 or 15, or it really doesn't matter. There is my 10 milliliters. So I have all my reagents, the KMNO4, the iron, the ferrous ammonium sulfate hexahydrate. And so now I begin the titration. But what am I going to do? I'm going to run it from wherever it is up to around 20 before I worry about anything happening at all. So just run it. Of course, this time I can't have anything being trapped on the side because this is the real run. And of course, I'm watching this 0.5. I want to go to something like 22. Yeah, let's shoot for 22. Where are you, 22? 14? $17. All right. Let me lift this up so you can better see the numbers. So now I'm going to add my phosphoric acid. You can see a tint of the yellow in there. Maybe not so obvious on the video, but there's a tint of yellow. I put in my phosphoric acid. Much of the yellow goes. Now is when the careful work begins. You can run it a little, but of course I'm looking at my solution down there and seeing what it's doing. Drop by drop, and kind of as you get closer, decrease the drop rate. So basically, if you are careful, and of course you are, you should be able to see the end point within delivery of 1 drop. All right, there we are. Within what drop went to that color. So now our job is to read the burette as best as we can. So that's 25, and there is the 5 mark. So then there is the 26. 25.6, and so I'm going to read this as 25.65. You guys cannot quite see the bottom of the meniscus, but that's where I'm shooting at in order to read that. So 25.65 milliliters was titrated. All right, perfect endpoint, no excess there. So we know what the original volume was. You can go back in the video and read what it is, and that's the final volume, so we know how much was delivered. One more. The third and final one. Here it is. Right, that's just water. Just make sure stuff didn't get stuck on the side. I'm gonna get my sulfuric acid. Call for 25, but I put in 29 or whatever it is, doesn't really matter. It's an excess reagent. Put it in. I'll start mixing to dissolve the ferrous ammonium sulfate compound. My stirrer is not working. I think it's just not plugged in the other side. So let me switch. Let's dissolve that. Meanwhile, we'll get our phosphoric acid ready. Again, about 10, 15, 20, doesn't really matter. It's an excess reagent. All right, so now we get to the point where we need an accurate reading of the starting volume. Where is that? Where are the numbers? So it looks like 1, 2 there. So I'm gonna read this as 2.10. Bottom of the meniscus, 2.10 milliliters. That's our start volume. And then we think, okay, we need to put in 22. So I'm gonna run this to 24 before I start slowing down. All right. Starting at 2.1, I'm going to run it all the way to 24. $18, $19, $20, $21, $22, $23, $20. Wow, stop there. All right, little yellow has developed there. I'm gonna add my phosphoric acid. That just sharpens the end point. All right. So now is drop by drop, watching what's happening in the solution. Again, my hands on the controller here. controlling the rate, now decreasing the drop rate right there. Right there is nice tint of the potassium permanganate in our reaction chamber. So now, of course, the objective is to read the blue red. So I'm gonna read this as what? We don't get quite to 27. Kind of hard to do on the video there, so I'm gonna read it for you. Let's read this as 26.9. 26.90, bottom of the meniscus there. You'll note that we don't really quite get to the big line with 27. So, initial volume, final volume, initial volume, final volume. We can now do the calculation. How do the calculations go? Well, from the grams, 0.5 or whatever it was, we can go to moles of the ferrous ammonium sulfate compound. Then what? Then we can go to the balanced equation and note that they react 1 to 5. One of the Chem 4 to 5. So now that we know the iron, we can certainly figure out the moles of the permanganate that reacted with the iron. Once we figure out the moles, we can convert the liters delivered from the milliliters into liters and go moles per liter and find the concentration here and find the concentration in the previous one, and we'll be asking you to find an average.